Cool, right. Good afternoon, everyone. This, the final talk, refactoring CSS without losing your mind. It's a pretty big talk, so I need to keep my pace. I need to keep my pace up quite a lot. The talk is going to look at, firstly, some fairly philosophical approaches to refactoring. When should we refactor? What's the business case for refactoring? Is there a business case sometimes for not refactoring at all? I think that's quite an interesting thing to look at. Then after we've discussed this kind of stuff, we're going to move forward and look at actual tips, techniques, and strategies for refactoring CSS. Now, I mentioned CSS quite a lot. This talk is specifically about CSS, but a lot of the techniques that are discussed here can work in kind of any other amount of programming languages. So real quickly, yeah, I'm a consultant front-end architect, which means that I travel around and work with lots of different clients. I tend to work with them discussing things like CSS architecture, design process, performance, and just kind of the nature of the clients I work with. This tends to happen at scale. I tend to work with typically larger companies who've got bigger products, bigger teams, larger code bases, older code bases, which obviously you can imagine means there's going to be a lot of refactoring CSS that happens. And unfortunately, I really don't enjoy refactoring CSS. It's a horrible job. CSS is a horrible syntax. You can't write proper tests for it. It all operates globally, so it's really hard to refactor it safely. Just hands up, who's refactored some CSS before? Oh, most of us. Leave your hands up if you enjoyed that experience. There's like 8 suspicious people in the crowd, okay? It's not fun, right? It's not easy. It's pretty difficult. So hopefully, during this talk, we will find out some ways to make it a little more sane, a little bit more manageable, and just a slightly more predictable experience. Kick off with a definition. I always find it helps to kind of define things up front, so we're all discussing the same kind of thing. So what do we talk about when we talk about refactoring? There's a really clever guy called Martin Fowler, and he describes refactoring as the process of changing a software system in such a way that it does not alter the external behavior of the code, but improves its internal structure. I think that's a really nice definition. It kind of sums up every aspect of refactoring for me. It's a thing that the business or the team does to improve its internal structure, and hopefully the customer will never notice, right? It's a private thing that the business decides on. So what I'm getting from this is that refactoring isn't really for our users. It's not something that we do for our users. Certainly not in the first instance. I would argue that if given enough time or over enough time, our users definitely start to benefit. So it's not directly for our customers' sake, but eventually the customer will be used to more consistent code bases with fewer bugs, fewer regressions. We can also ship features much more quickly if we are working in a nice, tidy product. If our product is easy to understand, easy to navigate, easy to extend, we can begin delivering features much more quickly. To my mind, and certainly for the purposes of this talk, there are 3 main kinds of refactoring. The first kind is kind of as-you-go refactoring. This is the kind of refactoring that we should be doing all the time. For example, we might prototype a new feature, and we see that the feature works quite well, and we should integrate it into the actual production code base. When we do that integration, we are going to tidy things up, we're going to dry things out, we're going to start documenting and commenting things. So as-you-go refactoring is stuff that we do constantly just to keep things nice and neat. The second kind of refactoring I'm going to be talking about is technical debt. I find technical debt a really interesting topic. Technical debt is basically a strategic decision to take a shortcut right now, safe in the knowledge that in 2 months' time you're going to spend a little more effort tidying things up properly. So technical debt isn't a bad thing. We shouldn't see it as a bad thing. Technical debt is a strategic development and business decision. It just incurs interest, and we'll discuss this more in detail. The final kind of refactoring is the rewrite or overhaul, and this is the bad news. This is where we don't want to end up. This is when we ignored the as-you-go refactoring, we ignored our technical debt, and all of a sudden we have to just tear everything down and start again. I'm sure a lot of us in this room have been involved in rewrite projects, and they're not very nice, right? It's kind of admitting defeat, admitting that we need to start again, and it's kind of demoralizing, and it's quite expensive. Which brings me on to this. oftentimes what I find is that as we progress through the lifespan of the project, as we go further on with the project, the type of refactoring we encounter changes, so that as you go, refactoring is going to be happening quite near the beginning of the project. We don't normally encounter technical debt until a few phases or months into the project, and then at the very end of the project, we have the very expensive rewrite and overhaul. As you go, refactoring might cost you minutes to hours of your time. Technical debt could be days to weeks of your time, to rebuild a certain feature. And a rewrite or an overhaul is weeks to months, right? This is a very expensive type of refactoring. It's expensive for two reasons. You need to fund those few months to rebuild the entire platform, but also it brings a huge opportunity cost, because the month that you spend rebuilding the platform, a month that you could have spent building new features. So what you're doing is you're actually spending a lot of time and money getting back to kind of feature parity. So what we need to do is we need to try and catch everything as soon as possible and avoid going down this kind of timeline. We're also going to discuss the overlap of each type of refactoring, because there are certain points at which we can stop one becoming the other. We can nip things in the bud and stop them progressing into a more expensive type of refactoring. Technical debt, then. Let's have a quick detour and talk about technical debt in some more detail. I really do feel that technical debt is quite a misunderstood term. Who's heard of the phrase technical debt, for starters? Okay, so I'd say about half of us. Technical debt is a really good metaphor for discussing the quality or the amount of hacks or nasty things inside your code base. Technical debt is when you take a shortcut immediately, you take a shortcut right now to deliver a feature quickly, but you know that that shortcut needs tidying up. I think the best example of technical debt in CSS is important, right? Important costs 3 seconds to type. But we know for a fact that when we refactor that important out in 6 months' time, it might take 3 days to actually fix the underlying problem. So the most succinct example of technical debt in CSS, just think about important. 3 seconds to implement, 3 weeks to fix. Really nice article that talks about technical debt in a lot of detail. A debt means that you acquired something right now in exchange for a long-term financial burden. This burden isn't just about repaying what you got, there is also interest involved. It means that even if you pay your debt timely, you'll pay more than you took, and if you don't, your debt will keep increasing. If you ignore your debt for long enough, it will become unpayable and you will go bankrupt. This is the rewrite. This is where you ignored problems in your code base for so long that you go technically bankrupt. You have to rewrite. So, technical debt, it's going to happen. On every project, we can expect some technical debt. It's naive to think that we won't encounter some technical debt. But what is important is that we keep up repayments. We need to make sure we schedule in time into our sprints or our development work. We need to make the business case for tidying up technical debt. So the longer we leave these subpar bits of code in our project, the more expensive they become to fix in the future. Making and proving the business case for refactoring can be quite difficult. A lot of the companies I work with, development teams tell me that one of the things they struggle with most is convincing their managers to let them tidy up the code base. I'm sure a lot of you may have felt that same frustration yourselves. So when should we refactor and what should we look at refactoring? My kind of easy, cheating answer to this is just you should always be refactoring, right? There's something you should be doing. There's always something that could be tidied up. But to give you a proper answer, I would say there are a few occasions when we should start refactoring. The first one, the simplest one, is if the projected cost of maintaining something is higher than the cost of refactoring it, then we should refactor. If we've got a problematic feature that slows us down, if we've got a feature that developers don't like maintaining because it's poorly documented, it's very fragile, it's got lots of browser hacks, actually keeping that feature running is going to be quite expensive. Perhaps it's going to be cheaper in the long run to tear it down and replace it with a better version. So yeah, if the current version of something is slowing you down, perhaps look at refactoring. And on the flip side, even if the current version of something isn't slowing you down, there may be a much better alternative which will increase your speed like tenfold. So it's not always about if the code is bad right now. Sometimes it's about, is there a substantially and tangibly better alternative that we could implement? This is a little exercise I often use with clients to discuss when we might want to refactor something. It's an imaginary scenario. We've got two versions of a code base. We've got the code base as it exists right now. That's the first column. And in the second column, this represents what the code base would look like if we were to refactor it to a point where we were happy with it. And the rows sort of demonstrate the addition of a certain feature. So for this example, let's think we've got a CSS project, quite a large old project, and all of a sudden a customer wants a theme, right? They want their version of your product to look like their branding. Now, the CSS framework you built may have never intended a theme to be involved at all. So you've got two options. We could hack a theme in to keep that client happy, and it might take 2 days. Or we could refactor the code base so that theming is a first-class citizen, and then add the theme in at the same time, and that might cost 7 days. Right here, immediately, we can see that refactoring is by far the most expensive option. But we have to be good at estimates and projections, because if we think that, well, we're going to make theming part of the platform, if one client gets theming, we'll roll it out everywhere so that all the clients can get theming. The next time we get asked for it in the current code base might cost us 2 days again. The third time, we've got a hack on top of a hack on top of a hack. So it might cost 2.5 days. This is the interest, right? The cost is going up. Conversely, if we were to refactor the code base at a cost of 7 days, perhaps making theming a first-class citizen reduces the cost of implementation to 1/4 of a day. So what we can see is over enough time, the cost of refactoring actually is less than the persistent hacks. The key thing to realize here is that, one, you have to be good at your estimates. Developers hate giving estimates. I don't like giving estimates, but we have to be good at it, have to get better at it, and have to be confident. And secondly, it's all about projections. If we refactor the code base and add the first theme, and then nobody ever asks for a theme again, we've actually lost 5 days of time there. So we have to be certain about the projected state of the project. The column on the right, the refactored code, represents investment. Technical investment is simply the opposite of technical debt, taking more time than necessary to plan for the future. Another interesting thing I cover with clients is I actually think it's quite important to understand when we shouldn't refactor things. There are certain times when refactoring is not a good idea. If you're not actually being slowed down by something, if something isn't actually causing you any problems, do not invest the time and money in fixing it. It's not wise to spend money that doesn't need to be spent. Out of context, this slide just reads like terrible advice, right? You know, if it's something that can be ignored or avoided, that sounds terrible. What I'm getting at here is that if it's a bit of the project that we very rarely have to work with, if it's a bit of the project that very rarely surfaces itself, perhaps we can just leave it to exist. Even if it isn't perfect, we can hopefully leave it to exist, thus saving money. If it's something that can be captured by a rewrite later on, I've worked with a number of clients who have, they've said to me, in 12 months' time, we're going to rewrite the entire application. But in the meantime, we'd just like to tidy bits up. And my answer to them is usually, if you're going to throw it in the bin in 12 months' time, is there any point polishing it now? Can we just leave it for that 12 months? Can we try and squeeze a little bit more out of this code base? It's all an exercise in saving the client money. And sometimes, if a rewrite is a better solution, I'm sure most of you in this room have inherited a project that's been a complete mess, and you've decided that you're going to start trying to tidy it up. And after a couple of days of trying to tidy it up, you just realize that this is so bad that I ought to just start again, right? I'm sure we've all had that. So sometimes a rewrite can be the better solution. Some specific examples of when I have encouraged people not to refactor things. I had a client say to me once, we would like to refactor all of our CSS onto the BEM naming convention. Now, I really like BEM. Anybody who knows me knows just how much I like BEM. But I don't think spending 2 weeks refactoring your entire project onto a new naming convention is going to pay itself back very quickly. I don't think that's a wise investment. However, if you can get the numbers to prove that it is worth perhaps 2 weeks just to rewrite your naming convention, then the numbers prove that it's the correct thing to do. But something as superficial as a naming convention, or anything just new and shiny, sometimes might not be worth implementation, might not pay itself back very quickly. Another good example of when I told a client not to refactor, they put this in an email. They said, oh, we want to do a bunch of things, blah, 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 and we think the code for the nav is quite ugly. I popped open the code for the nav, and they were right. It was horrendous. It was awful. But I had a few questions for them, because I was worried that they were just refactoring out of pride, right? Just refactoring because they didn't like how something looked. The first question is it actually causing you any problems right now? And it turned out that the nav was completely accessible, It worked in every browser, on every device, every screen size it needed to. The nav wasn't actually causing any problems. The next question I asked them is, how often do developers have to work with this code? Is it costing developers a lot of time having to pick through this nasty, tangled mess? And it turned out that if a user or the customer added a new item in the CMS, a new page, the nav would just get that new item and display it, right? There was zero manual maintenance involved with this nav. It just kind of looked after itself. So no developers were being slowed down by working with this code. So my third question is, can we just leave it alone? Do we really want to spend the next 2-3 days refactoring a nav that will not actually give us any benefit? We'll spend 3 days doing it. That will cost us 3 days. But we're not going to sell 3 times as many products on the site because the nav is just sort of slightly refactored. So this was a condition, or sorry, this was a circumstance in which we decided not to refactor. OK, so I want to talk about a concept that I came up with earlier this year. I was working on a fairly large refactoring project with a client, and I wanted to help them understand the actual process of refactoring anything. And I came up with this metaphor of a refactoring tunnel. A refactoring tunnel represents the journey through a kind of refactoring project. The metaphor goes like this. You pick something you want to refactor. You pick a thing in your project that you want to refactor. On day 1 of refactoring, you step into the refactoring tunnel. You can see the light behind you where you just came into the tunnel, but you can't see the light at the exit, right? It's round a corner. You can't see the light at the end of the tunnel. Day 2, you continue refactoring. You can still see the light behind you, but you still can't quite see the light at the end of the tunnel. And you keep going, and then after day 5, you find yourself somewhere in the middle of the tunnel. You can't see the entrance anymore, but you still can't see the exit. And you're lost, right? You're lost in this refactoring task, and you don't know where you are, and you end up doing this. I've been guilty of this so many times. I spend 5 days trying to refactor something. The nav's broken. For some reason, the footer doesn't work on this page. The responsive layout doesn't work anymore. The SVGs have stopped showing. And I'm like, shit, how have I managed to get here? And I just have to throw everything in a bin and start again. Honestly, show me if you've done something like that before. Yeah, there's probably more of you. This happens all the time, and this represents a long refactoring tunnel. This represents a refactoring task that was just too long. We picked something that had too much surface area, it touched too much of the project, it took too much time, and it left everything broken. We need to avoid long refactoring tunnels. A long refactoring tunnel would be anything with a large surface area. For example, refactoring all of your CSS into Sass affects 100% of the CSS project. This is a very long refactoring tunnel. That has a huge surface area. Refactoring all of your naming convention from suit to BEM, for example, that's a huge, huge task. That touches 100% of your CSS. That has a large surface area. This is a long refactoring tunnel. We need to pick much shorter tunnels. So avoid refactoring anything that runs through the entire project. It takes too long and leaves things really messy. You start to get really specific developer problems with doing this kind of refactoring. Merge conflicts. Imagine if you renamed all of your classes from one naming convention to another. It might take you a week, right, including testing. Imagine trying to merge that piece of work into master. That's going to be an awful task. So big refactoring tunnels, long refactoring tunnels, lead to very specific problems such as merge conflicts. And also, if we're refactoring a whole lot of the project, it's really easy to inadvertently introduce new bugs, regressions, etc. Instead, pick short tunnels. Pick really small things with a limited scope and work on them very rapidly and in isolation. For example, just refactor the nav. You might have a big task in front of you to refactor all of your naming convention, but instead of doing that as the entire CSS project, just refactor the nav. And then, once you've done that, bring it back into the project, and then you've got a decision to make. You can either continue refactoring. Perhaps you'll refactor the header and get that onto BEM, and then refactor the sidebar. Or you could decide that, well, actually, what's more important right now is this deadline, and I need to go and join the other developers shipping features. And it means that you're not tied up for weeks and weeks and weeks on refactoring work. You can get back to product work as well. Keep doing this, and then the site ends up refactoring itself. Before you know it, you've done enough small bits of work that the site has refactored itself. These short tunnels that we pick off, it's really important to refactor these in isolation. It makes very little sense to rewrite your CSS back into the same stale code base that it came from. The problem with CSS is that, of course, it inherits and there's the cascade, and it leans on other things, and there are other things that can affect how things look. So let's say your reset is horribly out of date. You refactor your nav back into the same project, you're going to be recycling the out-of-date reset. Then in 6 weeks' time, you decide to swap the reset for normalize.css, and all of a sudden, the nav that you've just refactored breaks again. There's no point refactoring features back into a stale code base. What you want to do is take a feature, decide on what it's going to be, go out to CodePen or JS Fiddle, rebuild it there, and then, once it's finished, bring it back into the project. For example, we might be working for The Guardian and decide that, well, we've got a task to switch over to SVGs, we want to use this new naming convention, and certain other things. Identify a sensible component with a limited scope, a short tunnel, and go and rebuild it somewhere else. Go and rebuild it so that it uses all the new features you need, and then port it back into your project. Now, of course, as you can imagine, we're going to get some kind of breakages if we just try copy and paste new CSS straight back into old CSS. We will get regressions, we will get collisions. This isn't going to be a very smooth process. So the next tip I want to talk to you about is something called all initial. Show of hands, who's heard of all initial? There are like 2 of us, right? We should go and get a beer later. The rest of you aren't invited. Right, all initial is a fantastic property. It basically effectively stops inheritance. It sets all CSS properties back to their initial value. It stops inheritance. It stops things leaking in. This is a really good way of refactoring legacy CSS. On your brand new refactored bit of code, drop all initial. All the legacy stuff will not get in and interfere with your new CSS. Very progressive way of dealing with things. I've put the word progressive in here because we will have to talk about browser support in a couple of slides' time. But it is a quite nice new feature we can use when refactoring CSS. I'll try to pull out a little demo for you, but I'm not sure you'll be able to see it on this screen. Hopefully, you can see we've got some red text in the bottom part of the screen. That's because body has color red applied to it, and div has font weight bold applied to it. The text inside the paragraph is red and bold. As soon as we drop all initial into that paragraph rule set, the text goes back to being black and font weight normal. So what we're doing here is we're stopping inheritance. There are some oddities with all initial. It's not completely plain sailing. Imagine we refactor our nav, and we call it nav primary, and we drop all initial on there. And we call the linked nav primary link, and again, we drop all initial in there as well. Unfortunately, nav primary link will not inherit the font size or font family from nav primary anymore. We've put all initial in there. The link is going to get reset to its original state. The simple fix for this is we just move any of these inherited properties down onto the leaf node. We just drop those at the very bottom of the DOM tree. Everything renders correctly. I mentioned browser support. Browser support for this is quite interesting because we do see a lot of green, but we see 2 very significant portions of red. IE and Edge do not support this property at all, so we can't use it for 100% of everything we refactor. What I normally recommend all initial to be is buys you a bit more time. The regressions will only be visible to a small proportion of your users. It buys you a bit more time to fix regressions. So drop all initial in, work quite rapidly, make sure you're refactoring things, fire open IE whatever you're testing at the moment, and work out what's happened there. What all initial does is it just buys us a little bit more time. In a similar kind of vein to all initial then, the next thing I want to discuss is something called defense.css. Defense.css is a very specific solution to a very specific problem. The question was asked of me by a client, what happens when we need to run refactored code and legacy code side by side? The client that asked me this was a company called Sky. They're quite a big broadcasting company back in the UK. I used to work for Sky sort of 3-4 years ago, building their UI toolkits. And they're building a new UI toolkit, so they asked me to come back in and consult. So they had this existing toolkit. They wanted a new one with a modernized design, modernized architecture. And we wanted to integrate it. But because it's such a big company, it employs about 31,000 people, we couldn't just roll this out across the entire platform. I'm sure you've all worked in projects where you want to go responsive, and your managers say, let's make the home page responsive first, right? Because that's how CSS works. So we picked the homepage as the first candidate to become using the new toolkit. And all of a sudden, we had a problem. The entire website, the entire sort of domain, sky.com, was using old and new frameworks side by side. This would also be like using Foundation and Bootstrap in the same project. It's two competing ways of working that are existing in the same global scope on the same project. As you can imagine, when you try and put old and new together, the outcome isn't particularly nice. We got a lot of collisions, a lot of mess. We got this horrible kind of point where old and new were just not sitting together very nicely at all. What we did to kind of smooth out this point of integration was we just invented a third project. So we had old CSS, new CSS, and defense.css. And all defense.css was a third-party internal bit of open source, which we just consumed, and it was a library just full of all the nasty hacks and fixes that it took to get this thing working again. So it was a whole new project. It was its own new dependency, its own new repository, and it was just full of nasty, hacky, horrible CSS. The thing here is, that's fine, right? We don't mind this being full of horrible CSS. The whole point is that old.css will get deleted one day. But all the fixes we need in the meantime, we don't want to put those in our brand new toolkit. We don't want to fill our brand new greenfield CSS project with fixes and hacks for legacy. So we just stuffed them all in this third-party file. The other reason we put them in a third-party file was it meant that other teams could consume it. So if they were rolling out the UI toolkit across help and support, they could install defense.css and already get the fixes we'd done. And it also meant that when they found their own bugs, they could contribute fixes back upstream and other teams could make use of them. So this file was just full of all the nasty little bits of hacky CSS to get things working again. I was wanting to show you some examples of CSS that are in this file, but I read the code of conduct, and I think it would be too offensive to show you, so I had to pixelate it. You can't really see that anyway. If you can see on the screens towards the middle of the room, you might see here is a lot of red, right? There's a lot of red around here. That's just important, right? We've just slammed all this stuff in there. It's disgusting. It's offensive. It's the kind of CSS you just type until things work properly. I've worked with developers who seem to do that as a living, but yeah, defense.css was designed just to get things fixed until we can get rid of it completely. The next tip I want to discuss, a real simple one. RF classes. An RF class is basically any refactored bit of CSS where you've modified the class name or introduced a new class name, prefix it with RF hyphen. What this does, it tells the next developer that, OK, this has got an RF in front of it. This has already been fixed. This is brand new CSS. I didn't ought to modify it, but I could probably reuse it. And anything without the RF is obviously old CSS that needs fixing. We can also do automagical things like this. If it's a class containing the string RF hyphen, put a green border around that bit of HTML. We can hide this behind a feature switch in our Sass, and we can turn this on and just see visually what has been fixed and what hasn't. So for example, we can see on this site, the nav and the content blocks have been fixed. They've been refactored. This is the work that we've already done. It's a very visual way of seeing this state of the project mid-refactor. Conversely, we could write a selector like this, which is just find me a class, find me every class, but make sure it's a class that doesn't contain RF hyphen, and put a red border around it. And all this does is it shows us what hasn't been refactored. Here we can see that the weather in London masthead has been tidied up. That's clearly new CSS. The rest of it represents the work that is left to do. Once we've deemed our refactoring project complete, we can just do a find and replace and get rid of every RF hyphen in our Sass or less or whatever style sheets we're using. And if RF hyphen seems a bit too kind of dangerous to do a find and replace, you can pick any other prefix, right? It doesn't have to be RF. It could be anything of your choosing. The next thing I want to look at is refactoring specificity. If you're refactoring a legacy code base, you're probably going to find that it's full of IDs or nested selectors, CSS that is just pretty nasty that's still going to conflict your new stuff, right? If you're moving to a nice single class-based low specificity architecture, you've almost guaranteed that something from the legacy CSS will override your new stuff. We just need to make sure we handle this relatively safely. We don't want to start filling, again, we don't want to start filling the new CSS with loads of horrible IDs and importance. So what we can do is we can hack specificity around with very few side effects. I want to show you a few party tricks. I guess don't come to one of my parties, because I'll just show you CSS. But let's take a real simple piece of HTML, right? We've got a link. We can bind onto this HTML 3 different ways. We could grab the A element, we could bind onto the foo class, or we could bind onto the bar ID. And if we do that, we will find that even though hash bar is defined first and it's got two things defined after it, it's the one that will be applied because this is just how specificity works. So what we've got here is three very differently weighted selectors who are working opposite their source order. And one thing we're taught very early on in CSS is that source order is critical. This is why specificity is so horrible, because it kind of inverts the paradigm of the cascade, right? It's not a nice thing to deal with. What we could do is we could just stick a load of importance in here. We could increase prominence by doing that, but we should never use important in anger. We shouldn't use important to fix the symptoms of a problem. It's far too nuclear. It's far too heavy-handed. Instead, what we can do is we can hack specificity around. We could rewrite an ID selector as an attribute selector, and that reduces its specificity to one class. What we're doing here is we're normalizing the specificities of each of these selectors to make them all identical. Every selector now has the exact same specificity, but we didn't once have to refactor any HTML. We didn't have to refactor any views. We don't have to go into templates. We can do this all through our CSS. The next one, html.foo, has an element and class level specificity. And the final one, :root A, has a class equivalent specificity and one element. This means that the final selector is the one that gets applied. Just to pull this out onto a more digestible slide, rewriting IDs as attribute selectors brings their specificity down from an ID to one class. This means if you get third-party widgets or legacy HTML or HTML you can't edit, perhaps it comes from a CMS, and it's full of IDs, you don't have to put those IDs in your style sheets. You could use an attribute selector and select them that way. The second one, we can chain classes with themselves to increase their specificity. So .foo has the specificity of two classes, but only one string of FOO actually exists in the HTML. And we can do this infinitely. We could put a billion classes next to each other and keep increasing the specificity. And finally, if we ever need to increase the specificity of an element level selector, what we can do is we can use the root pseudo element, or root pseudo selector, sorry, to target it that way. The root pseudo selector represents the top level DOM node in a document. So in HTML, it's the HTML tag. In an SVG, it would be the SVG tag. And in XML, it would be the XML tag. So root just represents the topmost sort of DOM node, and it will always be present, and it carries one class level of specificity. It's important to stress that these are hacks. These are not nice things to do. These are not cool, right? These are not things we should do as standard. These are basically what we do if we cannot get to the HTML. These are what we do if we do not want to introduce IDs. Ideally, we would refactor everything until this problem goes away, right? In an ideal world, we would just spend the time refactoring everything completely and get rid of the problem. None of us live in an ideal world, right? We're not going to get the time to refactor everything every time. So more realistically, we would use one of these hacks to nudge our specificity around. The benefit of these hacks is that they are less drastic than important. And it also means that we don't have to start writing heavily nested selectors. We don't have to guarantee a certain DOM structure. The whole point of all these hacks is that we don't have to start saying, well, if the button is inside this box, do this. We could just put button.button next to each other, and it means we don't have to rely on a certain known DOM structure. Basically, we should never use important to get out of these kind of problems. Using important, as we discussed earlier, is one of the quickest ways to achieve quite severe technical debt. Because specificity can't be reversed, we can't just opt out of it. We just have to keep adding more and more weight to our selectors, and we get the specificity wars. Important does have a use case that kind of falls out of the remit of this talk. There are times when I would recommend using important, but fighting yourself out of retrospective specificity wars is not that time. Use one of these hacks instead. On the subject of hacks, has anybody heard of shame.css? Oh, cool, a few people. Shame.css was a thing that I came up with about 3 years ago with Chris Coyier. If anybody knows, you probably all know Chris Coyier. Me and him were chatting about where do we put the nasty, hacky bits of CSS that live in our project. Of course, Again, in that kind of mythical ideal world, there wouldn't be any hacks, but we're going to have deadlines, we're going to have releases to get out, we're going to have to hack something at some point. The way we deal with those hacks is really important. So the idea of shame.css is that you have a totally new style sheet reserved just for your hacky code. Code that you have to write to get a release out on time, but code that makes you ashamed. So basically, this file is similar to defense.css, but it's a more global place to just drop the bits of CSS that you're ashamed of. The reason we use the name shame.css is because it's meant to be quite lighthearted, but we need to make sure people understand that having to do this is a shame. We don't want to have to do this, but we're kind of circumstances are out of our hands. The importance of shame.css is basically that it isolates these hacks. It puts them in a very obvious place. It means they're very easy to find. They're very easy to spot. It means you're not burying hacks throughout the rest of your nice, clean code. Instead of your code base being full of like to-dos, we've got a file that is all of them in one place. Makes it very easy to find and fix things. If you have a technical debt task, or if you're having a sprint where you tidy up some nasty old code, having it all in one file makes it a lot easier to tackle. You can pick things off the list. An example entry in a shame.css file may look like this. There are certain things that are kind of mandatory here. We need to explain the problem, explain why we dropped the hack in there. Just typing the hack in this file isn't any use to anybody. Explain why the hack exists and what problem it solves. I found in my career as a developer that just by explaining something or apologizing for something, I can get away with doing a lot more nasty stuff. So just by dropping a little apology in the file, tells people what to expect. And it also suggests what you would do to fix the problem if you've got enough time. So if I had enough time, if we didn't have a deadline, I would actually go and do this. And it just gives the next developer a clue as how to go about fixing it. And again, here we can see we're just chaining these two classes, the button.button classes, to increase their specificity. If anyone can't see this slide, I'll tweet a link to the slides as soon as I finish the talk, so don't worry about that too much. So shame.css, it's a self-writing to-do list. Drop all your nasty, hacky bits of code in a dedicated file. This is what you fix next. This is a list of your entire CSS project's technical debt. It keeps good code nice and clean. So let's assume that 95% of our CSS is quite nice, and the 5% is just hacks and fixes for different browser inconsistencies. When we are working in that 95% clean code, we don't want to be reminded that the nasty stuff exists. Has anybody heard of the broken windows theory? Show of hands. A few people. The broken windows theory is an interesting kind of social theory that comes out of New York, right? The analogy goes that in New York, if there is a government-owned building that's vacant and somebody smashes a window, the New York Council sends somebody out immediately to fix that window. Because if they don't send someone out immediately to fix it, somebody else sees it as a smashed window and they'll break another one. Then the next person sees that there are lots of smashed windows and they might break into the building. And it's kind of this steady decline that the analogy works against buildings, but I think works really well against software projects. As soon as you go to a software project, or a CSS project specifically, and you see an important, you're going to feel a lot less guilty about using an important yourself. Shame.css moves all that nasty stuff out of the way. It means that for 95% of your working day, you are looking at nice, clean code that kind of sets a standard. You will feel like a bad person for kind of dropping that standard. So it kind of reminds you of the quality of the majority of the project. You can see which parts of the code base are particularly problematic. I haven't had to use this very often, but I'm sure you've all had this before, right? You're a front-end developer, and a designer comes to you with a really crazy, complicated design, and you say, I could probably build that, but it's going to take a lot of hacky, nasty stuff because this isn't supported in these browsers and blah, blah, blah. And the designer says, well, yeah, the project manager's already showed it to the client, and the client signed off, so that's what we have to build. And you're just left in this horrible, horrible position of, you're going to look bad not being able to fulfill this, right? It kind of reflects on the front-end developer. If you put all the hacky, nasty bits of CSS inside shame.css, you can actually work out what percentage of that file was caused by this one feature. You could go back to your product owner, your project manager, and say, this feature that I told you I thought would be problematic actually contributed 179 lines of hacks to the project. It gives you some actual numbers to work with. if this one file gets full of hacks from the same features, you can start to identify that feature as being a problematic feature that probably needs a redesign or a rethink. And finally, I always feel really bad with this one. It's just easier to run git shame across one file than it is across your entire project. This isn't necessarily to find out which developers aren't doing a good job. A very specific thing happened to me a couple of years ago. I was working on a project back in the UK, and I was kind of the architect on phase 1 of the project. And phase 2 was getting taken internally, so I was leaving the project, handing over, and we had like a day's workshop to hand over this CSS architecture. I said to the developers, do you understand everything? And they were like, yeah, we understand everything, it's fine. And I came back 2 months later to kind of drop in on the client and see how things were going, and I noticed that the shame.css file was absolutely full of hacks, and the hacks were all from the same developer, all on the same feature. Now, this wasn't me thinking, this is a bad developer. This made me realize that the one bit of the project I didn't explain most thoroughly was the one bit of the project he was struggling with the most. It was the grid system. I hadn't explained the grid system very well, so he was having to hack it around to get it to work at different screen sizes. And all it took was, I grabbed a coffee with him, took 15 minutes, and I was like, well, this class here that you've added actually already exists back in this file, and we can get rid of that. So keeping all your hacks and your tech debt in one specific file also allows you to see who is struggling with which particular features, who needs more training, who might need more information regarding certain things. The talk's winding down now. We've got a couple of slides left. I want to leave you with, I want to discuss or tell you about a really interesting perspective, a really eye-opening perspective that I had shared with me about 2 years ago, 3 years ago. I was running a workshop in London. And every kind of public workshop I do, I go around the room and I ask everybody, what's your name? What do you work on? What kind of clients do you have? Are you freelance? Do you work for a company? And we got to one guy who said, oh, actually, I've only been a web developer for like a couple of weeks. I'm actually a civil engineer by trade. I normally build bridges or build roads. And I was like, oh, that's really interesting. Like, how are you finding life as a web developer? And he said something that really stuck with me. He said, well, as a civil engineer, I don't really get to refactor my architecture. What I love is that as a web developer, I can change things as I learn more about them. I can go back and refactor things as I learn more about how the project behaves and how it evolves. So yeah, as a civil engineer, he didn't get to refactor his architecture. Think about it. If you build a bridge, you have to get it right first time, or 200 people lose their lives, right? A pilot can't refactor a failed flight. A surgeon can't refactor a failed heart surgery. We're in a weird situation, a really nice situation where we've got this second chance. Refactoring for us is a second chance that a lot of industries just don't get. For the longest time, I viewed refactoring as a horrible job, something that I didn't want to do, something that I didn't want to have to do, something that felt unproductive. But as soon as I realized that I'm in a position where I can learn about my CSS, or any code for that matter, I can study it over a few months and learn about its inefficiencies, and change it however much I like without any side effects, that's really quite compelling. And this guy, I don't think he realized just how much this little story meant to me. But it made me completely reconsider what I view refactoring to be. OK, so let's summarize. Remember, prevention is cheaper than the cure, right? Catch things as early as possible. Try and convince your managers to let you do refactoring work before it becomes a rewrite. If your manager still isn't too keen on giving you that time, do it under the radar. Add an extra half day onto every feature and use that half day to tidy things up. It's our responsibility to do this refactoring, because it's us who have to deal with the code that we produce. Technical debt is fine. Do not view technical debt as a bad thing. Technical debt is a strategic business and development decision that allows you to sort of get more velocity. You just have to remember to keep up your repayments. Only refactor when you see tangible benefit. Don't refactor out of pride or out of just wanting something nice and new and shiny. Make sure you can prove the case for refactoring. Avoid long refactoring tunnels. Don't pick off bits of work that go through the entire project. Define small, clear bits of work and refactor them rapidly. And finally, isolate and highlight everything. Make sure that people can see your old, nasty, hacky CSS. Make sure they can see what is nice and new and refactored. Make sure everything is very clear so that people don't end up deleting new work or recycling old work. The last thing I'd like to say then is there's a really nice quote from a guy called Sir Robert Baden-Powell, and he founded the Scouting movement. He famously told his Boy Scouts, always leave the campground cleaner than you found it. And I think we have a similar responsibility as developers to leave the code base cleaner than we found it. Thank you very much for your time.